So in this video, we are going to focus more on the parallelogram law of vector addition. We are going to learn how to find the resultant force and the direction the resultant force makes with the positive x-axis. Now, if you are new here, make sure you subscribe to this channel, like this video, and share this video to all your friends. In this particular video, we are going to solve 3 questions. Now, let's start off with the first question. Determine the magnitude of the resultant force acting on the screw eye and its direction measured clockwise from the x-axis. So we are going to find the resultant force and its direction measured clockwise from the x-axis. Now, because we are going to consider the parallelogram law of vector addition in solving this question, let's look at some fundamentals of this particular law. Now, let's assume that we have 2 forces acting at the same point. Let's consider this to be F1 and then this to be F2. Now, to complete the parallelogram, we need to draw lines that are parallel to both F1 and then F2 to intersect at a common point. So starting from the head of F1, let's draw a line that is parallel to F2. Also from the head of F2, let's draw a line that is parallel to F1. So the 2 lines intersect at this point. Now let's call this point P and then this point O. Now let's draw the resultant force, and that is Fr. So this happens to be the resultant of the 2 forces F1 and then F2. So considering the properties of a parallelogram, let's assume that the angle between these 2 forces is phi, and the angle between F2 and this line to be theta. Now, these 2 angles are said to be supplementary angles according to the properties of a parallelogram. Therefore, we have phi plus theta equals 180. Normally, you'll be given the angle between the 2 forces, that is phi, and then you need to find the angle theta by subtracting phi from 180. Let's also assume that we have the angle between Fr, which is the resultant force, and then F2 to be alpha. Now, if F2 lies on the positive x-axis, then the angle alpha becomes the angle between the resultant force and the positive x-axis. However, if F2 does not lie on the positive x-axis, then you may need to perform extra calculations in order to find the angle between Fr and the positive x-axis. Now, to find the magnitude of Fr, we are going to use the cosine rule or the cosine law. So that is given by Fr equals the square root of F1 square plus F2 square minus 2 times F1 times F2 times cos theta. So this is the cosine rule. Now, to find the value of the angle alpha, we are going to use the sine rule. So for the sine rule, we have sine alpha divided by the angle opposite to alpha, and this line is parallel to F1. So we have sine alpha over F1 equals sine theta, and then opposite of theta, we have the force Fr, that is the resultant force. So basically, we are going to use these 2 formulas. 1 to find the value of the resultant force, and then 2 to find the angle the resultant force makes with the positive x-axis. Now, after we have understood the parallelogram law of vector addition and how to apply both the cosine and the sine rules, let's solve this particular question. So for this question, we are given 2 forces, 6 kilonewtons and then 2 kilonewtons, and then we are asked to find the resultant force and its direction measured clockwise from the x-axis. So we are going to move in this direction, that is the clockwise direction. So first of all, let's find the resultant force Fr. Now to do so, we need to draw two lines which are parallel to both F1 and F2. Now let's consider this to be F1 and then this to be F2. So from the head of F1, we draw a line that is parallel to F2. And then we also do same for F2. We draw a line that is parallel to F1. And then we have this to be the resultant force, Fr. Now from this point through to this point is 180 degrees. So to find the angle between these two forces, we need to subtract 45 and then 60 from 180 to get the angle between these two forces. So that is the angle phi. So we have phi equals 180 minus 60 minus 45, and that's equal to 75 degrees. So we have this angle to be 75 degrees. Now since these two angles are supplementary, then it means that if this is 75, to find the value of the angle theta, we basically subtract 75 from 180, and then we have theta to be equal to 105 degrees. So this is the value of this angle, theta, 105 degrees. Now since we have the values of the two forces and then we know the angle theta, we can use the cosine rule to find the value or the magnitude of Fr. So that is exactly what we are going to do. So to find Fr, we have Fr equals the square root of F1 square plus F2 square minus 2 into bracket F1 times F2 cos theta. Now let's substitute the values of F1, F2 and then theta into this equation. So we have F1 to be 2 kilonewtons, so 2. So we have 2 square plus F2 is 6 square minus 2 times 6 times cos 105 degrees. So after simplifying this, we are going to get 6.7979 kilonewtons, and then we are going to leave our answer to 2 decimal places, that is 6.80 kilonewtons. So that is the magnitude of the resultant force Fr. Now let's find the angle formed between Fr and the positive x-axis in the clockwise direction. So we are moving this way in the clockwise direction. Now to do so, we need to find the value of this angle so that we can add up to 45 to get the angle we are looking for. However, since we don't know this angle, we first of all need to find the angle alpha so that we can subtract alpha from this full angle, which is 75 degrees, and then we can get the value of this angle. Now let's call this angle beta. I'm going to take it again. We want to find the angle formed between the positive x-axis and then Fr in the clockwise direction. So from this point through to this point. However, we know this angle to be 45 degrees, but we don't know the value of the angle beta. But we know this angle to be 75 degrees. So to find this value, we need to find the angle alpha. Then we subtract the value of angle alpha from 75. Then we can get the value of the angle beta. And then we can add to 45 to get the angle we are looking for. So first of all, let's find the value of the angle alpha. So in doing so, we are going to use the sine rule. So we have sine alpha divided by, now opposite of alpha, we have this side which is parallel to F1. So this is F1. So sine alpha divided by F1, we have F1 to be 2 equals, we have this angle to be theta. So we have sine theta. Theta is 105 degrees divided by, now opposite of this angle is FR. So we have FR to be 6.7979. Therefore, we have sine alpha to be equal to, we multiply 2 by this whole value. So 2 times sine 105 degrees divided by 6.7979. And then this is equal to 0.2842. So we have alpha equals sine inverse of this value. And then we have alpha to be equal to 16.51 degrees. So this is the value of the angle alpha. Now to find the value of the angle beta, we are going to subtract alpha from 75 degrees. So we have beta equals 75 minus alpha, which is 16.51, and that is equal to 58.49 degrees. So this is the value of the angle beta. Now to find the angle between FR and the positive x-axis in the clockwise direction, then we are going to add 45 and then beta. Therefore, we have the direction to be 45 plus beta, which is 58.49. Therefore, we have the direction to be 103.49 degrees. This is the angle between the positive x-axis and FR measured in the clockwise direction. Now let's take the second question. So for the second question, the two forces act on a hook. Determine the magnitude of the resultant force. So we have two forces acting on a hook, and we are going to determine the magnitude of the resultant force. Now let's call this F1 and this to be F2. So like we did in the previous example, we are going to draw two lines that are parallel to both F1 and then F2. So we have this and then this, completing the parallelogram. Now let's draw the resultant force. So we have this to be FR. Now from the question, we are being given the angle between F1 and then F2 to be 40 degrees. And we call this angle phi. Now from the properties of a parallelogram, we know that these two angles are supplementary angles. Therefore, if phi is 40 degrees, then we can subtract 40 from 180 to get the value of the angle theta. So to find the value of the angle theta, we have theta equals 180 minus phi, which is 40, and that is equal to 140 degrees. Now, since we know the value of F1, that is the magnitude of F1 and the magnitude of F2, and we know the angle theta, we can find the value or the magnitude of the resultant force. So using the cosine rule, we have FR equals the square root of, we have F1 to be 200 newtons, so 200 square, plus F2 is 500 newtons, so 500 square, minus 2 times 200 times 500 cos 140. Now when you resolve this, we are going to get 665.74 newtons. So this is the magnitude of the resultant force, FR. Now let's solve the last question. So for the last question, we are going to determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. Now counterclockwise simply means anticlockwise. So basically we are going to take the anticlockwise direction. So first of all, let's draw two lines that are parallel to both F1 and then F2. Now let's call this F1, let's call this F2. So for F1, we have a line parallel to F2, that is this line, and then we do same for F2 parallel to F1. So we have this to be the point of intersection. Then we can draw the resultant force. So this is FR. Now we know that the angle between the two forces and this angle are supplementary angles. So how do we find the angle between these two forces? The angle between the positive y-axis and the positive x-axis is 90 degrees. Therefore, to find the angle between these two forces, we basically add 30 to 90 so that we have 120 degrees. So we have this angle, which is phi, to be 120 degrees. Therefore, we have theta to be equal to 180 minus 120, and that is equal to 60 degrees. Now, since we have the magnitude of the two forces F1 and F2, and then we know the angle theta, let's find the magnitude of FR. So using the cosine rule, we have FR equals the square root of F1 is 600 newtons, so 600 square plus 800 square minus 2 times 600 times 800 cos 60. So you can simplify this to get 721.11 newtons. So this is the magnitude of the resultant force. Now to the angle between the resultant force and the positive x-axis measured anticlockwise. Now to find this angle, we first of all need to find the angle alpha. Now the angle alpha is formed between the resultant force and then F1. So we have this to be angle alpha. Now to find the value of alpha, we are going to use the sine rule. So we have sine alpha divided by, now opposite of this angle is the line that is parallel to F2. So we have 800 newtons. So 800 equals sine theta. Now we have theta to be 60. So sine 60 divided by opposite of this angle is FR. So we have FR to be 721.11. Now let's find the value of sine alpha. So we have sine alpha equals, we multiply 800 by the whole of this value. So 800 times sine 60 divided by 721.11, and that gives 0.9608. So we have alpha equals sine inverse of 0.9608, and that is going to give us 73.90 degrees. So this is the value of the angle alpha. Now to find the value of the angle formed between FR and the positive x-axis, that is basically this angle. And we need to do that taking the anticlockwise direction. So in doing so, we basically need to subtract this value, which is 30, from the full angle alpha, which is 73.90, so that we can get the value of the angle between FR and the positive x-axis. So we have beta equals alpha minus 30 degrees. We have alpha to be 73.90 minus 30, and that gives 43.90. So this is the value of the angle beta, and that is the angle formed between the positive x-axis and then FR taking the anticlockwise direction or the counterclockwise direction. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.